Yeah, hi everyone. Myself Pradeep Sharma. So today's topic will be an introduction to the linear regression. And last topic we started with machine learning, that is volume one. In volume one, we were discussing about what is machine learning, what are the different types of techniques in machine learning, and we have done a few exercises in machine learning algorithms. So one of the very basic algorithm is linear regression. So whenever we start anything in machine learning, we start with the linear regression. Okay, so linear regression is another way of supervised learning because we have some data which is we can test and we can prepare our model and later on we can we can train the model and we can later on we can test the model and finally we get the our hyperparameters, or you can call the coefficient. So in today's agenda, we will start with the an introduction to the linear regression and why we need linear regression. What are the business requirement? What are the different applications for linear regression? What are the okay? What is linear model? What is dependent independent variables? What is slope? What is intercept? What is error variables? And how to validate your model. So to validate our model, we have least square method, linear regression in machine learning world. Then finally, we have few programs. We start the programs and we do some case study if time permits. So let's start with the intro. So linear regression is the as I told you that this is the simplest approach for supervised learning. So this is a one kind of you can say if you go to any internet page or when if you explore about linear regression, the first thing you will know about this is a one kind of term which is used in statistics. It is not new, it's already been used since ages, and though nowadays it is very much infamous because we have the data that is a very big data, and we can analyze our data with the machine learning algorithms. So linear regression is used to predict the quantitative response. That is why sometime we call this as a dependent variable, and the predictor variable, that is independent variable, that is x. So we have two variables x and y. For example, there's if you see below in the there's a age and spent. How much on the basis of age you are spending something means if you as soon as your age is growing, your expenditure is also growing. Okay, so there are two terms here. One is linear, another one is regression. So what is linear? In a simple term, linear in mathematical term, you can say it's a simple line. So linearity is the property of mathematical relationship or function, which means that it can be graphically represented as a straight line between the between these dots in, or you can say the values we pass in the plot. And the regression means it's a modeling technique, or you can say it's a modeling. We model our target variable. It's a kind of iteration you on your independent data. So this method is mostly used to forecast or give the prediction of the data and finding out the cause and effect between the relationship between two uh, variables. Okay. Okay, so we will. There are different linear regression. One is simple linear regression with the two variables, multiple linear regression where you can see multiple lines. And we in today's topic we will cover simple linear regression. If time permits, I will go through the multiple linear regression. So in simple linear regression, what is the use of this simple linear regression? Okay, usually whenever in business we want to take a decision, okay, managerial decisions, you can say managerial decisions are often taken on the basis of different kind of variables. For example, sales and profit. If my sale increase, my profit will definitely increase. For example, some risk. If you want to find out the risk and the purchase and some different kind of what is the pricing, so all these details you can find out with that with different variables. You put two variables in plot and find out the relation between these two variables. So to predict this relationship, we denote as I told that y-axis denote as an dependent variable and x-axis denote as an independent variable, and the relationship between these two, that is a straight line, is called sometimes the slope or the density means how much interaction between this. So it means on the percentage of increasing one variable, what is the percentage of value of increase in the second variable. In a simple linear regression, we involve one independent variable and one dependent variable. So if you see here, this in this line, if this is a straight line, it is growing. That means it's a positive, and this is a negative one. This is a negative slope. This is a positive slope. There is no linear relationship. This is not a linear. Okay, this is curve. Okay, so sometime when you start with the linear regression, you will find the data like this scattered in different. So this data is very much relevant, and this is totally different. For example, if you say the age and income, okay, so someone with the age of say 20, they're having a 5 lakh package. Someone is the age of 25 is having say 25 lakh a package. But in this age of similarly, you can say here, in the age of 45, people are having say 1 crore package. But there are people who are having more than 1 crore package, so 2 crore package. This is exception. So for these exceptions, we call this outlier. Okay, so we should not consider, we have to remove okay, whenever we start analyzing our data, what we do, we first find the minimum and the maximum mean of our data. If we get the mean of the data, for example, if you see here, the mean of the data is approximate, it will be near about here itself. Okay, so then we find out the distance between the minimum and the maximum. Okay, if the distance is very high between 2 points, then those points are called or treated as a outlier. So we remove those, we filter those things. If you are using a data frame, you filter those data in a data frame, you filter those variables and remove the data. Okay, let's proceed further. Okay, so whenever we start with the linear regression, usually we say there is an equation. Okay, this equation is called the regression model. That is y is our dependent. We want to find out, this is our target, we want to find out what is y equal to b beta 0 plus beta 1 x plus e. Okay, when we consider only simple linear regression, usually we do not include e. E is it's a random variable, that is error. Okay, whenever our model generates some value, okay, our prediction, between the difference between prediction and actual is called the error. Means how much and this is the what with this value we can identify how much efficient our model is. Okay, so let's read it. The equation that describe how y is related to x and an error term is called the regression model. Okay, the simple regression model is y is equal to beta 0 plus beta 1 x plus e. So beta 0 and beta 1, these are the hyper, sometimes we call hyperparameter, sometimes we call coefficient, sometimes we called some having some hidden figures, or you can say. So and e is the our error term. Okay, so this is the equation for linear regression. And if you plot a graph, if you like the graph which I was showing you here, okay, so this is your equation, and this is y, this is mx x plus c. C is your interest. When this if you extend this line, it interact here, that is called the c. When y become sorry, x become automatically 0, what will be the value of y? For example, if you have a vehicle, and if you take your vehicle from x place to y place, from this point to this point, the petrol if you put obviously if it is the 10 kilometer, for 10 kilometer, if it is consuming 1 liter of petrol, in that case 1 liter is your cost will increase. But what if your y is 0, for x is 0? That means if you're what you call that, if your vehicle is standing in your garage itself, but still there is a cost, there's a maintenance cost. So those, but still there's a y will increase. Y means money. So your money will increase, that your expenditure will increase. Still you are putting some value, some amount to your vehicle, that is called your what you call that, regular expenditures. Okay, so y equal to beta 0 plus beta 1 plus x is equal to plus E. That is a simple equation. When we treat with simple linear regression, we do not consider E most of the time, but we should, when we validate our model, we have multiple variables. So for example, b1 x, beta 1 x, beta 2 x1, beta 2 x3, beta 3 x4, like this. If we have multiple variables, or you can say multiple features, in that case we usually put E, because in that case E is very much compulsory. Okay, so graph represent a simple straight line. Beta 0 is your y-intercept. When your x becomes 0, then b0. If you see some other equations like y equal to mx plus c, like in my last session I was telling about mx plus c. M is your slope and c is your intercept. So you see different kind of equations. Somebody here say m plus c, somebody say x1 x1, like this. Anyway, the equation will be similar like this only. Okay, so the thing here is, when you get the data you will get y, sorry, you will get x most of the time. You in your historical data you have y is basically label. Okay, so you know that on the basis of salary we are giving some loan. Okay, if my salary is x, I'll be asked, yeah, loan can be given, loan cannot be given. Okay, but there are some other parameters which we need to see. If from the past or historical data we find out the value of these coefficients. I have few slides where we can show, and few programs where we can show means how we need to find out the values of x and c. Okay, so let's move further. So positive linear relationship, as I told, that if this slope is growing in terms of like both the things are growing, for example, x is growing and y is growing, then it's called positive. If it is down, for example, y is increasing, so sorry, y is decreasing, but x is increasing, in that terms is a negative slope. So the value of this will be, it will be beta 1 will be minus something, minus 2 or minus 3 or minus something. The value will be in minus. Okay, so how to get the model accuracy? So linear regression find the line that best fit in the data points. Okay, so uh, if you see here in the first slide, this is your prediction. Okay, you are saying that prediction means this will be always straight line on the basis of particular value. And for example, x is my this one, it will be treated, for example, x is my 100 and y will be 100, x will be my 200 and y will be 200. So for example, here x is 200, 75, obviously y will be on near about 75, like this. It is a straight. So what is the relation between these two? But sometimes this is my prediction and this is my actual values, and the difference between this point and this point, for I predicted the value will be this, but the value come like this when x value is this. Okay, so what are the other terms? This is called the errors. Okay, so this is best fitting you. That is why we call it regression. Every time we put a straight line, multiple times we are putting straight line with the same what you call that. Let me show you the uh, 1 second. If I draw a diagram for you, it will be more easy to understand. For example, this is my straight line y, this is my x, and these are the points. Okay, now if you have to draw a line, so usually what our algorithm will do, it will draw a line like this, and it will find the values, the difference between each and every point, from this point to this point, this point to this point, this point to this point, this point to this point. So this is what I predicted, and these are my actual values. This when I train the data, most of the time usually we do 0.25 is my train data, means 25%. Whatever data I have, out of 25% randomly it will choose as the train data. Then we will test the data and we will find out if the model is correct, then we will finally produce the data. Okay, so there's another line here you can see the difference between these two terms. Okay, the difference between this and this is more accurate, correct? But you can see here when I was finding the distance between this and this. So we have to draw multiple lines, and we need to find out which is the best fitted line for which will give you the minimum error and give the maximum output. Okay, so we usually find out, we plot the data and we draw the line and we get the difference between the actual and the prediction. So this is how basically our entire program means. So your algorithm will do like this. Okay, so this is a simple, let me draw another one. So if the data is like this scattered everywhere throughout this, then in that case, let me take the bigger one.
Pradeep, I believe you have freeze your screen. I guess your screen is freezed.
One second. Yeah, can you hear me now?
Your voice is audible. I guess your screen is freezed.
Okay. Can you see my screen now?
Screen is fine. Can you change your screen? Yeah, that's fine. I guess
One
you
second.
had freeze before, so could not make it. I request you, can you just repeat it again? Thank you. Go ahead.
Okay, sure. So I was explaining you guys, I have opened my MS Paint and I was showing you different lines. See here we have one line, but if you draw the different line like this, you will see the difference between these errors. Okay. So my point was here to show you the actual difference, or you can say the error between the actual and the prediction. This is my predicted points, but in the linear, I can't move my best fitted will be, for example, if you want to best fit, for example, like this, and then you pass like this and you draw a line like this, but that is not a linear one. Okay, so in that case, we can't move our line like this. Okay, so because it's a linear regression, we just plot the straight line, and we draw the difference between the two lines. Okay, so there are different methods to find out the model accuracy. One of them is least square method, where basically we find out the difference between yi and the difference between basically say what is our observed value and what is the estimated value. If you find out the difference between these two square roots, mission find the mean, and it will give you the least square method, least square values. Okay, so to find okay, now we have two values which we need to find out. One is beta 1, another one is your intercept. So intercept is easy to find out, because if your x becomes 0, it will be treated like, for example, if my x is 0, but here still, if you see in my screen, there is near about the value is 35. Okay, so this line will cross at y35 intercept. So y is easy to sorry x y is easy to find when x is 0, but in terms of b1, that's the relation between y and x. So we have a formula, that is summation of xi minus x bar, that is mean yi minus y bar, and the difference, and it will be divided among xi minus x bar, that is mean divided by square root of this, square of this, and we find the summation, and we will get the b1. So these all terms are related to statistics. If you are learning ML, you need not to be bother about it, because you just write a simple one line of code. For example, I'll show you the code. uh, so you just need to so if you can see here, one of the example here, I can show you. So in this terms, if you just put predict, automatically it will do everything for you. Okay, you need to use the linear regression. I'll explain you this very much clearly. I'll rewrite this an entire one uh, program. So you just need to understand. I just want to tell you that only thing which is here important is you should know about which algorithm I am using, what are the different functions are there, and how to find the coefficient and to find the intercept. For example, if you want to find the coefficient, you just need to remember this line: model dot my coefficient, model dot my intercept. It will give you the beta 1 and beta 0. For example, beta 1, you no need to write the code again, because it is already written in Skyline. Okay, so just to understand what is inside going on, I am explaining all these things, because whenever in ML world, you will not be going to use all these things, and you will not going to write your program in from the beginning of all the algorithms. So there's another method, that is gradient descendant. Gradient descendant is the method which is updating your A0 and A1 to reduce the cost function, MSC. Okay, so for example, if you want to go from here to bottom down, okay, you want to traverse like this. Okay, so what are the points which you need to take? If you take the long values, definitely if you take the 25, maybe directly you're jumping here from here to here, and from or here to here, or from here to here directly. So in that way you will skip this one. So in gradient descent, usually we move little bit slowly point, and we reach up to the down. So these are the different algorithms which usually we use in ML world to find out our what you call that linear regression validation. Okay, so this is a simple intro about what we are doing here. And as I told you, I have already explained about dependent and independent variables, and few other terms. Let me put some okay, so one point I guess I missed here is that is the uh, why we need linear regression. Okay, so in in statistics world, or you can say linear regression is basically referred to a model. That is model I have already explained you guys. This is the model, and this model will give you a relationship between two variables, that is x and y, to find out the coefficient of these beta 0 and beta 1. So all these things we do in statistics. Okay, so what is the general purpose, why we use it, and what is the applications of this in the business world? Okay, just take an example of a business, for example, in marketing company, and they do advertisement, and with the basis of advertisement, they get their customers, or they collect the data, and they find out what are the people using. So there are different examples. For example, sales of a product, you can find out the sales of a product. You can find the pricing of the product. What should be the price? If you take or distribute your sample, ask people what should be the price, and then you can ask for the performance. You can ask for you can take the find out the risk. What is the risk in taking this particular product in business, in market? So so linear regression is it's a very much powerful technique that can be used to find out the consumer behavior. And for example, in one of my earlier project, I was using linear regression in 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 some AML world, where we need to find out the behavior of the customer, and we were having multiple variables, and now in our slides you can see only one variable, but there are multiple variables which usually, for example, if you want to take let me open one. So how multiple variables will be, for example, okay, so y, if you want to find out the y, okay, so my c m x plus c, this is my normally I usually prefer mxm as a slope. So in this is a simple linear regression. In the terms of multiple linear regression, you will do m1 x1 plus m2 x2 plus m3 x3 finally plus c. C is your intercept. Okay, so what is this? These are the three variables x, y, and z. For example, in my advertisement company, x is my say radio, and y is a tv, and z is a newspaper. Okay, so for particular this xyz we need, okay, sometime when we do this to find out the y, maybe you I'm not sure you guys knowing about this. So for y we have y1 comma, it's basically it is a matrix y1 y2 then y3. Okay, so these are the 3 points you need to find out, and for this you need to draw a another matrix. For example, this it will be like x1 m1 comma m1 x2 comma m3, sorry, m1 x3. So my matrix will be like this. I just need to change the value of m here, 3 2 2 3. Now you need to find out the product of these two metrics. So obviously, you know the product. If you want to find out the product, you need to make it in a n into n format. And in the C for C, we have C1, C2, C3. C1, one second. C1, C2, and C3. So this is another matrix. So we usually we multiply all these metrics, and we find out the values of m and these values we will find out later on. We find out the value of y. So all these things are happening in background. Everything you do not need to worry about. Just I am giving the brief about how exactly it is happening here. So let's move to the coding part now. Okay, and let's take the new fresh one. So whenever we do, I need to make my kernel clean. Okay, this is my spider, and I if you in my last uh, session I introduced a spider. I have installed my anaconda. If you know about anaconda, you can install anaconda, and if you open the spider, you will get this view. I'm using anaconda in Python 2.7. You can use 3.5 or 3.7 also. So first thing first here is, let me increase the font. Okay, so this is a simple program I have already written here, and the thing here is you have some data. Okay, so two things: the data you can prepare some data, or if you are using sklearn, you will get the data from sklearn. Okay, so I'll show you how it is doing. Okay, so first we need to import few libraries. So I'll import my matplotlib for plotting the points. NumPy basically used for numerical calculations. Then I will use my sklearn because I'm using sklearn here for my linear regression. So what I need to do, I will as in sklearn linear model import my linear regression function, and then I'll import my data set. Data set is where your entire data is there. So how you want to use visualize the data? Let's prepare. Okay, which data you want to take? So I want to take the data which is called diabetes, diab EDES, diabetes data, and it's already inside your data sets dot you which data you want to load underscore diabetes. So there are different data sets you will find: diabetes data and digit data. Okay, so you can load others also. Let me see. So you can say Boston, breast cancer, diabetes, digit, iris data. Okay, most of the thing, if you go online and see, people are doing lots of exercises and providing programs on iris. So this is wine tester wine data. Okay, so I have to use diabetes data. So I'll use the diabetes data, and now if I want to understand what is the data size and what is the data volume, in that case I'll use simple diabetes dot data dot shape. Okay, if okay, one more thing. This is your object. These are the functions. You can see lots of functions are there. You can go through all this function one by one. Many helping things are you can get all these details if you install, or you can use you read the API. Okay, so int data dot shape. Okay, so let's calculate this one first. Every time you have to go press this is a shortcut. It's F9 you can use. So it's already imported. Now get the data. F9, you get the data, and finally you're getting the okay, there's a spelling mistake, I guess I did. Yeah, sorry. F9, you will get the data set here. So you here you can see there are 442 lines and sorry, row and 10 columns. Now I would like to understand about the what is the target shape. So to get the target shape, you just need to F9. It'll give you 442. So these are the features. I mean, these are the columns which are there: age, sex, BMI, BP, S1, S2, S3, different variables almost. If you see, these are the tens: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 variables. So 10 columns. 442 items are there. 442 rows are there. Okay. So now let's we have the data and we know the data. Let's see how we will prepare our first linear regression model. Okay, so as I told you, the equation will be y equal to mx plus c. Okay, so here let me put some. Okay, so what is x here? It is a data, that is your independent variable. We do not have control on x. Okay, for example, let me give what is the relationship between independent and dependent. If you will understand more clearly with the next another example. If there is example like raining is there, if it will be more rain, there will be more crops. So rain is independent. We have no control on rain, when and how much rain will come. But w- on the basis of rain, okay, what is the dependent variable? Crops. Okay, so this kind of relationship you can understand. So X is your independent variable, Y is your dependent variable, which is you can the call the target which you want to produce, and M is your coefficient, and C is again your coefficient. So what usually we call M is your slope, and C is your intercept. Okay, and plus E. Usually I do not consider E because we are treating as a, this is a very basic one. In simple regression we do not consider E much of the time. Okay, so now the next thing is I need to train the data. So to train the data, there is a method which we need to import from model selection. So I have to import it, sk learn dot model underscore selection. It will automatically populate. Then you need to import train underscore test split. Okay, so now we have to find of we have to get the four variables, that is x underscore train comma x underscore test. So we are preparing the data set from our historical data. There's some problem with my keyboard. X underscore train, x underscore test, then x y underscore train comma y underscore test, and I'll put simply train underscore test underscore split method, and I'll pass the arguments. So what are the arguments we need to pass? Okay, if you see here, there's an array. Array is your data set, and options. There are different options which usually we pass. So what is my data set here? My data set is this one: diabetes dot data. Okay, so let me show something here. Diabetes dot data. If I want to print it, what it will give me? There are different values it will give. Can you see? So these are the different values in our data set. So I'll pass this data, and what is my target? My target is this one. So I have to pass my target value. Okay. Then what is the test size? Usually, if you do not provide, by default, it will take 0.25. Okay. So I will provide 0.2, comma. Then another one is random state. I'll provide 0. Okay. So what are these terms basically? Okay. So there may be a question like, what what are these terms? Why we use these? So one second. So for if you go and see the API of your what you call that taste set split API, you will get to know there are different methods and different what you call that variable target variables which you need to find, parameters which you need to pass. So I'll read a little bit few parameters for you so that you will be understand about rate. what are the parameters passed in train test split. So first thing usually we pass is the array, that is the data set. Then we pass our target. Then we pass the test size. We pass the train size. So every time the value should be always 0.0 to 1.0. Okay. So what is the possibility if you give here more, what you call that, if your training data is very much similar to your what you call that prediction data, the test data, in that case your rest of the things, what you call that, your result will be more accurate. For example, if my model know all the possible points in the plot, then obviously I'll pass a very good accurate line. But if I have less data and I'll train it on and get the MNC value, and then I put the MNC and in some different data and get the value, in that case the value will be not accurate, because it is a test data. Okay, so we pass the test size, we pass the train size, we pass the random state size, we pass the shuffle size, how much shuffle you want, and finally we pass the splitting size. So these are the different values usually we pass in our data set. Okay, so let's move further, and we would here, let me see, I have to run it. It will give you some error, and what it is saying that this is an invalid syntax. Okay, so the syntax by default x train, x test, y train, there's some spelling mistake, train set plate comma test size equal to 0 point. Okay, sorry, my bad, I put one extra. Okay, so ah, it is there, maybe some spelling mistake. Yeah, this is what happened when you write. Okay, it's accepted. I did not run this first line, so obviously it was not able to find it. Okay, so let's move. So my training is happen, and I have some. I have splitted my variables. This is my train data, this is my test data, this is my train data for y, this is my test data for y. Okay, so let's move to the next step, that is we need to find our linear regression model. So I have to define the model. So there are three steps. One is you need to set up your model. So to set up a model, we have a okay, I have already imported linear regression, so it should not throw error. Let me define it. Now model is already defined. So model. Okay, so now there are another thing which is fit, as I told you and I was explaining in that we need to draw different lines, straight lines, and find out the error. So now we have to use the fit method. Fit is basically used to generate the final means give you the particular line, and later on you can put the score. Okay, so now model dot score. So usually if you have seen here, we are training our data on trained data, and but we want to score or test it and get the score on test data, so we have to pass these two variables. Okay, let's train it, and finally you get the score value. This is my score value. Okay. Okay. Now you got the model. You have already trained it, and you prepare the score, but you have to find out the coefficient and intercept, so that if I put this coefficient and intercept in any value, I will get my prediction. Okay, so to get the coefficient, I told you coefficient is one method you need to put. This will give you the coefficient value, and my coefficient value was this. You will get the 10. Why we got 1 2 3 4 5 6 7 8 9 10, these 10 values? Can anybody answer? Okay, let me tell you. If you see here, we have 10 parameters. These are the 10 features. For every feature, we have to, for as I was telling you, there's a x, like I was drawing something. Let me draw it here. Y equal to m1 x1 plus m2 x2 plus m3 x3 plus c. So c is your intercept, and these three are your x1 x2 x3. These three are your features, and this m1 m2 m3 are these values. These are the coefficient values. That means m1 m2 m3 for your age, sex, BMI, means for all these 10 features, you got these values. Okay, so this is your coefficient. Now let's find out the intercept. Okay, can anyone tell what should be the intercept value? Means it's a 1 or 10. It will be only one value.
One.
Why? Because there is only one C. Correct. Now we have train data X. Okay, this is the score which you have produced, and the final score we got it. Now if you want to get the values, okay, if you want to predict as per the model which I ran now, if I want to predict, so I can use the predict method. And what are the parameters which we need to pass? Argument. That's what x I need to pass the x. So where is my x? X is, I have already trained here, so I want to test this one. So I will pass test value, and you will F9. You will get these values. So this is my prediction. Okay. Now, if I want to plot this, okay, I'll show you the plot. Let me get this into my y. This is my y value, correct? Y underscore predicted value equal to model dot x model. Okay, so this is my y value. Now I want to use plot. Plot, plot is my function. From where I get this PLT? Here. From my matplotlib pylab, I got my plot object, and here I have the function, and the values we need to find is y underscore, this is my test, comma y underscore, this is my pred. Okay, comma, and how you want to present it as a dot. Okay, this, okay, I always forget like this. So now I got my y, and these are my plots. So this is my plot for x-axis and y-axis. What is test versus your spread. Okay, so let's put into the more linear way. So I have to get this, and I want to show you a very neat, clean one, and I want to produce. Let's run it, and this is my line. So if you see here, this is my data which is plotted, and this is the final line which I have to go through. This is my predictive line. So in this way, you can train your data. You can give the only thing. Okay, now one more thing I would like to show here is for my linear regression. This is a simple one. If you want to change to some others, so for example, random forest or gradient boost or some other XGBoost, whatever algorithm you want to use, only this function will change. Rest of the things will be almost same. The only thing will be you will get some different parameters, some different values, some different plot will be totally different. So you need to plot in different manner. So this is how usually we do our what you call that linear regression problems. Okay. So let me show you if anything is pending here in our agenda. Okay. There is another example I can take here is this is my data. This advertisement company, as I told, that on the basis of TV, these are different variables, values I have. I have this is my target variable. And so this is my Y. These are the X1, X2, X3. Okay. So on the combination of this, I'm getting this value. Okay. So if I put this into our, what you call that, there's another example. If you see here, let me make it a bit larger. Okay. So I have advertisement. I take it. I pass the feature names as per this. Please do not change the feature name. It should be as it is. If you pass TV here, it will, for example, I'm passing TV and save it. Okay. Okay. And if you run this one, it will give you error. Let's take this one by one. Then this is my data. This is my. It will take. Okay, maybe that file is totally different, or it not get got saved. Oh, it failed. Okay, so and now the data is there. You have passed the feature values. This becomes your X, and Y value is sales. That is this one. Y is my sales. Now you train the data like I told you. Train, test, then X, Y, train Y. Simply put the linear regression fit, predict, and put the same things. It will give you the output. If you want to do it, you can run it again, and it will give you the. See, now you got the error, correct? TV not in index because we changed the TV. Let's change it to TV. Now run it. It will give you this prediction value. What is finally we are printing? This is a mean squared error. Okay, so my percentage of error is this much. Most of the time we need to reduce this one. If you want to print this one, These are the values, different values for y after prediction. This is my prediction. So in the similar way, if you want to give you a plot, okay. So let's plot it. Okay, do I use any net plot? No, I have not used here. So I want to first use my plot here. Imported. Now I want to do the X prediction as test. Okay, is my X test there? Model. I'm not using any model here. Model.predict, X predict, Y plot. Let's try this one. Okay, Y pred is this. Y pred. Okay, okay. This is my trending. This is the data. So in this way, you can give the X is NP lineage. This X is X, Y, X, Y. Let's try this one. Yeah, good. Okay, this is bigger one. So we need to reduce this values. So what is in our case? The values are 25, 22. So I have to give you here 25, and the difference between these two is say 5. Now if you plot, it will be more accurate. Yeah, good one. So this is how usually we do the linear regression, and this is a very basic kind of algorithm. In our next sessions, we will go with the gradient boost or GBT, or we can go for a random forest and few others also. So let me show you a very simple mind map. If you have ever seen this mind map for ML algorithms, I have already saved it somewhere. I don't know. One second. Let me find it where I saved it. Okay. I I think I left it somewhere. I will find it again. Maybe in next session I will show you the mind map. I have already downloaded it somewhere. Okay. Let me see this one. This is no, this is not one. So in my next session, I will show you the mind map. This mind map is basically all the algorithms which we can use in machine learning, and it start with the regression, classification, and what falls into regression, what falls into classification, what falls into uh, supervised, what falls into unsupervised. All this segregation is been done there. So this was my agenda for today's session, and if you have any questions, you may ask. This is a very vast topic, and this is only 1 hour is not very much sufficient. But though I was a little bit fast sometime, and sometime I was missed few of the things because there are so many things. If you want to understand more about it, you need to join any statistics course, or you need to read about some statistics books, because these terms is not new. These are the already been used since last ages, and statisticians are working on all these things. This is new for us in ML because we we are recently started with all these things in uh, ML world. Previously, when researchers were doing some research, usually they take the small set of data, that is sample data. Those data was, now we have the luxury, we have big data like Hadoop and distributed computing. We can put any number of records. For example, in my project, we are using billions of records, and that has been, those linear regression is running very fine with billions of records and passing everything in, you can say, in couple of hours. Any question? Anybody? Or we can wind up. Okay. So that's it from my side. Thank you guys. Thank you for joining. Thank you. Yeah, over to Verma.
Uh, Thanks, Pradeep. So the session recorded will be available to your website onto the webinar blog. We'll upload it into this page so you can get this all the video recording for this webinar to the page. Okay. Hope you enjoy the session. So happy learning and wish you a very happy Diwali. Take care.